It would probably be a good idea to watch this entire video before attempting any of the analysis, as I made some changes as I went along. I think probably the biggest change that I made was using a frictionless or rolling slider constraint. After opening the step file in Inventor 2020, I grounded all of the components so that I don't accidentally move them. Then I want to measure a distance on one of the parts to make sure that the size makes sense. We see that it's 3.75 inches, which that was our expected size, so we're okay on that. We might go to Tools, Document Settings, and check the units. We see it's inch units, but when this was brought in as a step file, it sets our angle as radians. I'm going to change that to degrees. I'm then going to open up each one of these parts individually. I'm going to open up the handle, and I'm not going to run any feature recognition on this, but I do want to run a quality check. I'll right click and I'll select repair bodies, and I'll select find any errors, select all, and I get a green check mark that everything is okay with that. Now I've already assigned the material brass to this. Notice the appearance is showing here as brass, but the part itself isn't showing as brass. Expand the solid bodies and right click on the solid body and go to properties and select clear all overrides, and it still didn't change, so let's right click again, and I'm going to set this as a brass appearance and select clear all overrides, and this time we have our color. I'll save that and close it, and then I'm going to open up the base plate. I've already set the material to steel. I'm going to again right click and go to appearances or properties on that, and I'll select clear all overrides, and I'm going to select a steel polished color, and I'll right click and go to repair bodies, and I'll check it to find any errors. Green check mark, everything's okay. I'll save that and go to the next part. I'll open up the housing, and let's go ahead and I've split this with the clamping faces where the fasteners will go, and I will run the repair bodies, find any errors, we get a green check mark, that's okay. I'll expand the solid bodies, right click, go to properties, clear overrides, and I'm going to set this as steel polished. Save that, close it, and I'll open up the latch bolt. I've set the material to malleable iron. Let's check the part itself, select repair bodies, find any errors, everything checks out okay. I'll expand the solid bodies folder. I'll go to the properties, clear all overrides, and let's see if there's an iron cast appearance, and I'll save that, and I'll go back to the assembly. Okay, so there is my assembly. I will save assembly, and then I'm going to go to environment stress analysis. I've already set this up and tested it out to run it a couple times. In my first analysis, I didn't set the soft spring, so if I go to edit study properties, we see that I have it set to detect and eliminate rigid body modes. I copied that study and changed a couple of other settings, and on this one I edit study properties, and I'm going to select detect and eliminate rigid body modes to add a soft spring. That will stabilize the model so this latch isn't moving. I then on the loads I put the 1,000 pounds force pushing up on that face, and then for the contacts I changed the contact so that I have bonded on this side, bonded on this side, bonded between the handle and the latch, and then another bonded between the handle, the cylinder on the handle, and the hole in the latch. And then I have a separation no sliding on this side and a separation no sliding on this side, so as this pushes up this face can separate from the base plate. And then I have sliding no separation on the side here, 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 over on this side, and also up the top, the two faces up the top where that contacts it. When we run the analysis, we get a message that the model has separated into two independent components. This is expected behavior as the latch and the handle are bonded into one component and the housing and base are bonded into the second component. With detect and eliminate rigid body modes set, Inventor automatically adds a soft spring to stabilize the model. If I go to the stress, I see that I have a high stress area right where this edge meets this edge, here and here. The rest of the area is not very high stress. For my displacement, I have a minimal amount of displacement, and for my safety factor now, I have a low safety factor where that high stress is. So think that the stress is equal to force divided by area. The area where this edge is contacting that edge is close to zero, and so we end up with a singularity or a high stress area in that area that we can probably ignore that high stress, as we know that this edge of this is going to get rounded off as we use this assembly, but it really has no effect on the overall performance of the assembly. I've brought an imported step file. The first thing I'm going to do so that I don't accidentally move any of the components is I will fix them in location. I next want to check my units, so I'll go to the options and document properties. I'm going to set my standard to ANSI, and I want the units to be set to inches. And while I'm here, let's improve the image quality so that our circles look like circles. I'll then measure one of the edges to make sure that it makes logical sense, and I see that that edge is 3.75 inches, so that's what I'm expecting. So always check your measurements and check your units to make sure that it makes sense. I'm then going to open up the handle, and I will right click and I'll run import diagnostics. I see that I have one issue. I'll attempt to heal that. I successfully healed it, and then we will set our material, and let's set this material as brass. I'll save the file and close that one. I'll go to the next one, so I'll go to the housing. I'll open the housing. I'll run my import diagnostics, heal any errors, and let's set this material to 1060 alloy. I'll save the file and close it. I'll do the same thing for the base plate. Open that part, and we'll run our import diagnostics, and we will also set our material to 1060 alloy. And we'll do the latch. I'll run my import diagnostics, heal any errors, and let's set the material to malleable cast iron. Save that and close that. Let's go back to the housing, and I'm going to open that again, and I want to split the clamping faces on the housing. So I will start a new sketch on that face, and then I'll draw a circle, and I'll scrub the edge for a minute. That finds the center. I'll draw a circle out from the center. I'll scrub this edge, draw a circle out from the center, grab that edge, draw a circle out from the center, and one more. I'll then dimension one of these circles as 0.625. Make sure it's inches, and I see my units are showing in this one. Let's change that to inches, and then I will edit that sketch again, and I'll hold down the control key. I'll select these 4 circles and make those all equal. And then I'll go to the features tab, and I'll do split line. I want to split this face and this face. And so now I have those split. Save the file, go back to my assembly. Alright, so I want to run an analysis on this, so I will go to the simulation tab. I'll run a static analysis. I want to put a fixed constraint on this bottom face, so I'll go to my fixtures. I'll say fixed constraint on this bottom face, and let's just pin that. I'll say accept to that one, and then I want to put a fixed constraint on this face, and I'll accept that one. Now I'm going to do these as separate fixed faces. We could do it all as one, but later on we'll see a reason for doing those separately. Then I'll do this one, and I'll do the last one. Alright, so we have 5 fixed constraints on the bottom, and then the 4 faces. I then want to apply a load on this bottom face, so I'll go to external loads. I'll do force on this face, make sure my units are inch, pound, seconds, and I'm going to do 1000 pounds force pushing up against this face. Right now I need to define the contact between the various components. It might be easiest if I temporarily hide this housing, so I'm going to go to the housing, and I'll hide it, and then I have a cylindrical face down inside for this handle, down inside of the latch bolt. I'll go to my connections advisor, and I'll do contact set, and I want those to be bonded. So I'll select bonded, and first let's do this outside face. So I'll select this face, and then I'll do second selection, and I'll right click here and do select other, and I can get that face of the handle. think. So I've got that circular face of the handle, and then I'll do this again. So I'll do contact set again. Let's pin this, and I will right click in this area and I'll do select other, and I can get the circular face of the handle. And notice it's split into two faces, so I'm going to get the top face and I will right click again, select other. I got the bottom face. Now we'll get the top face of the handle, and let's set this as bonded. And then I'll go to the second selection, and I need to get the hole inside of the latch bolt. So I'll right click here, select other, and I'm going to get the imported face of that latch bolt, and I'll right click up here and select other, and I need to get the top imported face of the latch bolt. So I have those two faces, except that. So I'm doing these manually. We could do automatic and then change the types of contacts. Right, then let's go around to the bottom, and I'm going to go in this area right in here, and I'm going to set the no penetration, and I will right click in this area right here. I'll do select other, and I'll get the face of the base plate, and then I'll go to second selection and I'll right click again, select other, and I'll get the face of the latch bolt. I'll accept that one. Then I'll come over to this area, right click, select other. I'll get the face of the latch bolt or the base plate, and for the second one I'll right click, do select other. This time I'll get the face of the latch bolt, and I'll accept that. Alright, let's go ahead and leave that command for a minute. We'll turn on the visibility of the housing, and for the housing, this face right here, that planar face contacts against the inside planar face of the housing. So we'll do our contacts again, and I will manually, and I'm going to set that as no penetration. So I'll select this face and this face, and I did that both all in the same selection. So let's just clear the selection and do it again. I have no penetration, this face to second selection, this face, and then down here this face, and actually let's get it back there. So I'm going to clear that selection, and I'm going to get it back here, and then to second selection, this face, and I'll get it on this side, this face, second selection to this face, and then this face again to second selection, this face. Then I'm going to do this face. Now notice it's treating this as a split face here. Let's get the face underneath here first, and actually it's treating that as a split face too. So I'm going to move my mouse about in this location. I'll do my select other, and I want to get the face that's going all the way back along the housing, and then I'll right click and I'll do select other again for second selection. Now I'll do select other, and I'm going to get the top of the latch bolt, and I'll do the same thing on the other side. So I'll select other, and I'll get the face of the housing, second selection, right click, select other, face of the latch bolt. Alright, so we have over here, if we check our contact sets, we have the no penetration contact going around the latch bolt at the top on this side, top over here on the side, and the contact on this side, on the bottom, the bonded, and the bonded. Then I'm going to get the contacts on the sides. So I'll go to my contact set, and I'm going to put this as no penetration, and I will right click in this area. I'll do select other, and I want that face of the housing. I'll go to second selection, I'll right click, select other, and I want the face of the latch bolt. I'll accept that, and let's do the next one. Let's pin this, and I'll come down to this area and do select other, and I want the face of the housing, and second selection I'll get the select other, and I want the face of the latch bolt, except that one. Then let's go ahead and get these up at the top. So I will select other in this area, and I want the top of the housing, second selection, select other, top of the latch bolt, select other in this area, top of the housing, the top of the housing. And then for second selection, select other, the top of the latch bolt. We got two more to go, so I'll come over to this area, select other, the face on the housing, second selection, face on the latch bolt, and the last one, select other, housing, second selection, select other, the latch bolt. Alright, so let's check those. So if I go to my contact sets, I have the circular face on the handle is bonded. The cylindrical face on the handle is bonded. The bottom of the latch bolt to the top of the plate, the base plate, is bonded, or is no penetration. On the other side, between the base plate and the latch bolt, is no penetration. At the side, at the top, at the bottom of the side, up at the top, on one side of the top, on the other side of the top, and then on this side at the top and this side at the bottom. So we've defined our contact sets. Okay, now on this assembly though, this latch bolt isn't fully constrained in that it could move out of here. Let's see if it gives us an error. We'll first mesh the part and then we'll attempt to run it and see if it gives us an error that it is unstable. I'll go to create mesh. I'm going to go to advanced. I'm going to go to mesh parameters, and for the global size, let's set that as 0.0625. I hit the tab key and I see that it sets this all the way up to fine. I'll go ahead and create my mesh. So I wanted to have at least 2 divisions across the thinnest area, and we can hide that mesh now, hide my mesh, and I'll then run the simulation. So I'll run this study. Running the analysis with these contacts, I eventually got an excessive displacement warning. And so right-clicked on this analysis and did copy study, and also go to the properties and select use soft spring to stabilize the model. Since this latch technically not fully defined or fully constrained where it could slide back and forth slightly, we need to put a soft spring in here to stabilize the model since we're doing static analysis. All right, after I did that, I was then able to run the analysis, and let's change these units to KSI. So I'll double click on the color graph and I'm going to set it on floating, and I'll go to KSI, and I'm also going to change the background to white to make this a little easier to see, and particularly if you were going to put this into a Word document or lab report. And so we see our stress. We will go to the displacement, and I see that I have 4,000th of an inch displacement, or about the thickness of a sheet of paper. I want to display the factor of safety, so I'll right click and I'll select define factor of safety plot, and I'm going to set the upper limit as 8. And I see that my minimum factor of safety is well below 1. Let's change this color bar, and I want to set it to floating, and I'll do to 1 decimal place. And then I want to set it to show me the safety factor from 0 to 1. And so I'll have my maximum safety factor set 1, minimum set at 0. I know that the minimum calculated safety factor was 0.13, so I'll say OK to that. And so now I'm showing from 0 to 1, so everything that is blue is above 1, and if it's not blue, it's below 1. But let's look at where the minimum factor of safety is. It's actually just in this edge right along here, and in the edge right along there. And so we know if we push up on this that over time it's going to round off this edge right along here, and so that doesn't really affect the overall performance of the assembly. So we have to watch out for situations like that when we can see that most of the assembly is just fine as far as our safety factor is concerned, but it's only along this edge where we have a high stress or a low safety factor. For this lab, the first thing I want to do is import a neutral format step file. But before I do that, let's check our document units. And I know that the file will be in inch units, so I'm going to change the units to inches, and I'm also going to change my preferences to give me my analysis results in inch units. So then I will do open, and I will go to locate the file, and this one I've named lab 10, and I see a latch type block, and the first thing I want to do is check some of the sizes of the geometry to make sure that it matches what I expect to be the correct size. So I'll go to inspection, and I'm going to measure the length of this line, and I see that that length is 3.75 inches, which makes logical sense. If it was 0.375, that wouldn't make make logical sense. Or if it was 3.75 millimeters, that wouldn't make sense, but 3.75 makes logical sense for the size of this part. The next thing I want to do is apply various materials to the components. And actually, before I do that, I don't want to accidentally move anything from the positions where they are right now, because if we want to compare results, we need to be in a standard position. I'm going to lock the position of these parts. So I'll ground all the parts so that I can't accidentally move their relative positions to each other. Now, this grounding doesn't carry over into the FEA environment. For the handle, so I'm going to go to the physical material of this part, and I will go to metals, and I'm going to go down and find brass. I'll make this part brass. Now, if I go to the properties, it's showing me that it is brass, but I lost the color on that. So I will right click and go to the appearance, and I'll also drag the appearance brass onto this part. Now, I had to drill down into the brass folder, appearances, drag that into my model, and place that. Next, I want to change the material for both of these plates. So I'll select the housing, and I'll hold down the control key. I'll select the base plate, and I'll go to physical material for those two parts. And I'm going to go to steels, ASTM A36, and let's make sure that I apply that to these two components. And again, the colors from the imported file overrode the steel colors. So I'll go to the appearance, and I'm going to select, let's say, a steel brush linear long. I'll download that material, put it into my assembly. I'm going to apply it to this body, and I'll apply it to this body. See the appearance of that material. And then I'm going to change the material of the latch itself, and so I'm going to make this iron. Let's make this a malleable iron. So I'll drag that over onto this part, and again, I lost my appearance. I'll right click on the latch bolt, go to appearances, and I'm going to go to the iron folder, and let's do a cast iron appearance on this body. Okay, so now I've applied my materials, and I have applied appearances. Now the appearances aren't really necessary. I'll then go to the simulation environment. We're going to do a static analysis. I'm going to put a fixed constraint on the bottom of this, and then I will put a bolt through here, and the clamping face of that bolt will press against this plate in a circle. So I want to split this face in each one of these bolt locations. So I'm going to go to the simplify tools, and I will then create a sketch on this face, and I'm going to key for project, and I'm going to select these 4 circles, and then I prefer to change those to construction circles. So I'm going to select those circles, change those to construction, and then I'm going to draw 4 more circles. So I'll put a circle here, and a circle here, a circle here, and a circle here. I'm going to dimension one of these circles, and let's make that, let's say, 0.75 inches. And that's a little bit too big, so let's do 0.625. Now I notice that the units are being converted to millimeter units. So if I want to come up here and change those units to inch units so that it matches the rest of my analysis, so I'll do equal this one to this one, this one to this one, and this one to this one. Okay, now they're all the same size. I'll finish sketch, and then I'm going to do a split, and I want to split the faces, and I'll select this face to split, and for the splitting tool I'll select this circle, and it will only let me do these one at a time, so I'll have to do it 4 times. So I'll say okay to that. I need to make that sketch visible again, so I'll go to the sketches, make it visible again, and then I can do the split again, and I'll split this face with this circle, and then the same thing on the other side. So I'll do split this face with this circle, and split one more time this face with this circle. Once I split my faces, I will then turn off the visibility of the sketch. I'll finish simplify. I want to check my materials, so I'll I'll go to materials, and I see that for the handle I have brass, for the housing ASTM A36, for the base plate ASTM A36, and for the latch bolt malleable iron. Now if I want the properties of those, each one of these, I can select here for properties and record the properties of my materials in my lab report. I'll then add fixed constraints to these faces that I split, and I normally do these one at a time. I could select all 4 of them, but I prefer to do them one at a time, and we'll see why in a later lab. So as I'm doing this, I want a separate constraint for each one of these fixed constraints. So I end up with 5 fixed constraints, the one on the bottom and the 4 where the fasteners will clamp against this housing. I'm then going to add a load of 1,000 pounds force pushing up against this face, this location. Let's change that to 1,000. Make sure your units are pound force. Now if you wanted to convert this to metric units, simply substitute, or you could just type in the metric units. I then need to define the contact faces between the various components. So up here under contacts, I can do automatic contacts, manual contacts, or later we'll edit our contacts. For now, let's tell it to do automatic contacts. And so if it sees a distance less than this setting 4/1000 of an inch, it will establish a contact. So you have to be careful you don't put this number to be too big, because you don't want it to establish, say, a contact between this face and this face if they're not in fact in contact. And so I'll go ahead, and our faces are actually already touching each other, so there's no clearance between these parts, which actually in the real world there should be some clearance between these parts where this latch wouldn't be able to slide back and forth. Generate the contacts. If I edit the contacts for this first contact, bonded 1, as you push up on this, this could actually separate from this face. So I'm going to select that to separation, and then I'll go to the next one, and this one, this could slide along this face, but it's going to push up against that. I'm going to set that to sliding, and then for the next one, this face doesn't contact, so I need to really remove that one. Actually, I was incorrect. So we set a minimum distance of 4/1000 of an inch, but that's greater than 4/1000 of an inch. That contact is actually between the face of this and this face, and so that should be bonded. So we'll leave that as bonded. And then between this fastener cylinder and the hole, so that should be bonded. This one will be separation. This one will be bonded. This one will be bonded. This one will be sliding. This one will be sliding. This one will be sliding, and that one will be sliding. So as this latch pushes up, it can slide along that face, and this one will be sliding. Part can slide towards the front. So let's go back through all of these. This one should be sliding. This one is bonded to the handle, then the other bonded to the handle. Separation, bonded, bonded, sliding, sliding, sliding. And that one, I need to get that one to sliding, and this one is sliding, and this one is separation. I think I have all of my constraints set the way I want them. Now if you click on the edit pencil and select advanced, you'll see that there are a lot more options on how you can define your contacts depending on the type of contact. I want to measure this shortest area across here, and so I'll go to the inspection tab and measure this length, and I see that that is 0.125. I want at least 2 divisions across the thinnest area. Some users will recommend 3 divisions. I'm going to edit the mesh and go to advanced settings. I'm going to set the absolute size of the mesh as 0.0625, and then I will generate my mesh. I will then run my analysis. Now I notice that my pre-check failed, so I'll click, and it tells me that there is a degree of freedom. So I'm going to click here, and so this part is not fully constrained, which we know that it should slide back and forth. So we need to constrain this part. So in order to do that, I want to add a weak spring to this part. So I'm going to go to settings, and I'm going to remove rigid body modes, and that should add a weak spring to hold this in place. But I see that that doesn't fix it in Fusion 360, so that is a problem. So we know as we push up on this area, it's going to push against this face, and so this face and this face and the faces on the other side are going to slide up the side of this part, and then this end will push down against this base plate. So what I'm going to do is put a fixed constraint right on this edge and right on this edge of this part. And so if we're pushing on this right now, the way it's set, it could also slide. So we need to stabilize this model, and I was hoping that eliminating rigid body modes or adding a weak spring would stabilize the model. That didn't work, so let's do constraints, and I'm going to select this edge and this edge to constrain those two edges. I'll say OK, and it's still showing that this area is fully fixed. This is potentially fixed. Let's see what happens when we go ahead and run this simulation now. So it still gives us a warning, and so placing the fixed constraints here on these edges didn't work. So let's try another tack. I'm going to hide the base plate, and then I will go to simplify again, and I'm going to start a new sketch on this bottom face of the latch, and I'll P for project this point right here and this point right here, and then I'll draw a rectangle about like this, and then drag this point down to there. Now I'm going to put a dimension on here over to here. Now we could make this distance as small as we like. Yeah, we could assume that as we push up on this thing, it's going to lift up in this area over in here, but somewhere back in here it's not going to lift up. And so let's put in, say, 0.15 as that area that stays in contact. And then I'm going to split using that rectangle. So I'll split face, and I'll select this face, and this face is what I want to split, and then I'll select this rectangle and I'll say OK to that, and we'll finish simplify. And then I'm going to edit the constraints that we put on the edge. So I'll edit that constraint, and I'm going to control unselect those edges, and then I'll select these faces instead. Alright, I'll turn the visibility of my base plate back on again, and I'll go to my pre-check, and this time it tells us that everything is okay. We are ready to run the simulation. So I'll run the simulation, and I'm going to do this locally. I was able to get the Fusion 360 result to run, and again we have a low safety factor, but if I show this from, let's say, 1 to 0, we see that the high stress areas are right along this edge, and again that doesn't really affect the performance of the assembly, in that we would expect over time this edge would get rounded off. So I cloned the previous study and ran one more test, and this time on the constraints I deleted the constraints that I had on the split face on the bottom back here and replaced that with a frictionless constraint on this face, and that seemed to make it easy to solve, although I did solve online and it did take quite a while to solve that online. But I think that might be the best way to set this up to get it to solve. So if I drag my upper limit down here, so I see that the highest stress areas are in areas that we probably are not real concerned with, and it's just limited to a very small area of the mechanism, so we can probably ignore those minor high stress areas.